Happy Monday, everybody. Over the weekend, got the serial protocol working with Bluetooth, and it was quite a roundabout adventure to get there that started really last Thursday because I got all the documentation set, got the AIs working on it, and Friday basically spent all day just banging my head against the desk, fighting with the AI to try to get what I needed done. And eventually we got to where it was mostly working, but it felt like a very roundabout way of getting there. It didn't feel right, and I wasn't happy with the implementation or the process that we took to get there. So I fought with it a little bit more over the weekend, ran some more tests, and in the end I just was like, I'm going to start over and scrap all of the efforts done to this point and revert back to the last save. So that's what I did. But this time I wanted to try two different AIs. So I have a concept that I am going to be testing out and hopefully expanding on, but have basically a pod of multiple stations. Each station has a different AI, each one working on the same problem, and it's basically a race to see who can solve the problem the fastest. Part of the problem is I sometimes don't know which AI would be the best to be able to solve a problem. Sometimes Claude will go down a rabbit hole of just like reiterating and testing itself and verifying, and it's not really solving the problem. And I'll switch over to Gemini, and Gemini will be able to solve it real quick. But Gemini then doesn't have the full context for everything else, nor is it able to implement the other things as well as Claude is. So the concept that I've come up with is this pod concept where you've got multiple AIs. They all start with the same branch, or the same fork or branch. You branch off your code to where it's at. You build out your instruction set. So you go through the whole process of refining the next phase of your instructions to achieve an objective. And once that's refined, then you feed that in. They all have updated reference documents, reference context, updated instructions that are detailed out. Then you just start, and each one starts from the same place and will just make as much progress as they can. And the first one to win, to solve the problem, then gets reviewed by the others, and then that gets merged into the main branch and then reviewed, and we'll have another AI that actually goes through and updates and optimizes. And I think as this becomes a more efficient process, I'll have one that is specifically for updating the context of the code, so just constantly going through and making updates to the structure and the features and the capabilities and documentation and making sure that is squared away. And then the others will be basically fighting against each other to come up with the solution the fastest, then review it to make sure that it's robust, and then implement it. So I did a small batch test of that on Sunday where I started with Gemini, same context, same reference materials, everything, 2.5 Pro, and then I started with Claude. I reset everything that I had done from Friday, basically just like threw it all out the window, then just let them go and like stepped each one through it. Claude was the winner, actually very quickly. Gemini just completely like threw up on itself. It like pretty quickly into it, the code wasn't compiling, and it was never able to recover. Claude was probably within an hour able to come up with a solution, and it happened quickly, and it worked almost perfectly the first time. And the documentation was better, the test scripts were better, and the whole process just felt real clean and very efficient. And it could be because I had been using Claude primarily since Thursday or Friday of last week to like work to solve this problem. And so maybe it had the additional context that Gemini didn't have, but either way, like Claude won the day. And so pulled that over and merged it and had Gemini review it. Gemini had a whole bunch of suggestions for like the total code review and things that need to be looked at. So we'll be looking at that probably today. But that was the first test of that. So I think there's promise there, and we'll see how that goes over time. But yeah, so today is, now that is primarily done, my next step is to work with my software and engineering AI to figure out if where we're at with the implementation of the JSON protocol is in a good place, if it's robust enough to then move on to implementing features and capabilities. I've had it go through, review everything with updated context. It spit out a bunch of questions for me. I've thrown that back into Claude in VS Code to answer some of those questions, and I fed that back into my engineering team to further evaluate in that context. We'll see what the results are here in a minute and then go from there. And then I'll have that refined by Gemini's latest model as well. So we should have a pretty good plan going forward. And there may be more protocol implementation that needs to be done because I want the communication between the microcontroller and the host computer to be robust. So like if there's a problem, I need it to like reset itself and like basically get back going. I need to make sure that everything that's displayed on the screen is accurate Like that's obviously incredibly important. So like if it says Bluetooth is disabled, Bluetooth needs to be disabled. Same thing with Wi-Fi and whatever else. So there needs to be robustness built into the protocol, verifications, checks, all of that to make sure that what is displayed to the screen is truth. Got to make sure that this protocol is working right and the exchange is right. So I think we're in a good place. I think we will be moving forward, but I'll have to check with the AI here. Actually, all right, so we can do this in real time. Okay, so we've got good parsing of the JSON protocol. We've got auto detection for the Arduino, for the serial communications. We've got message queuing and throttling for outgoing messages from the host so that it doesn't overrun the microcontroller. Because I had issues where it would crash. The microcontroller was crashing, suspectedly because the host was just sending so many commands to it so quickly. So we built in some protections to prevent that. That's something that will need to be explored in more detail later, but for now I think it's good. It's working well. The JSON protocol structure implementation, the dispatch mechanism for different JSON types is well implemented. The handlers show the progress. Timestamps are good. We switched over to using Unix timestamps for just what's on the host computer to screen. Error statuses are well defined. Okay, so there's some areas that might need attention, at least with the context that my engine AI team has, saying that the current logic for the read loop for the JSON protocol seems to only process the next single line as a JSON, but if it's printed across multiple lines, then there's potential for it to happen. So if the messages are too big, we might start having some issues. We need to verify that, have that looked at eventually. I don't think for key that's essential. On the microcontroller side, it's well structured with clear handlers for different message types. It correctly strips the JSON of error prefixes from the host messages. The handshake logic for processing is robust, includes time sync and protocol version handling. So that's really important. We've got protocol version handling and time sync for messages that are going back and forth so that everything is current and accurate. And it's sending direct commands for Bluetooth toggling, which is important because the Bluetooth, anything radio related, directly handled. Okay, yeah. And then we've got test functions built in so we can actually test to make sure that things are working properly, simulated crashes or errors within the JSON structure to make sure that the recovery process is working properly. Overall protocol robustness, implementation parts, the protocol, the handshake, the button toggle, the error display appear to be robust and well handled on both sides. The dual approach for direct command versus prefix JSON is functional. The framework for adding more JSON message handlers exists, so that's good. So overall it looks pretty good. Next steps. All right. So it is suggesting that we move on to drive detection and basic information display to the microcontroller. So this is where we're going to build the drive monitor, and it will then start just actively looking for USB drives that are connected. I have had AI build this out in the past, so I know that it's the process that I think it's going to, but just need to get that into our code structure. So I've got a few more things that I want to verify with this. I will go back and forth, go back to the code base and get some of this looked at, make sure that everything that's suggesting is right. I'll have this reviewed by another one with additional context, and then we'll go from there. And hopefully within the next half hour, we'll have a pretty solid plan on how to move forward this refined. So that is today. Excited for it, looking forward to it. What an incredible time we're living in, to where basically we're moving to how you can manage AIs within your business for everything. I've got probably a dozen different custom AI, custom AIs, I don't know if that's the right terminology, but specific AIs with specific context and knowledge for handling specific problems or navigating specific issues such as software development or engineering, or I've got one for navigating federal government contracts because I don't know a whole lot about that, but I'm throwing a whole bunch of deep research into it. I've got one that specifically helps me with prompting for deep research so that I can get as much out of the deep research process as I can. And because it's got full context of my business, it can help me tailor the deep research prompt to my exact business, specifically in forensics, specifically in cyber, specifically in what I'm trying to do and implement for my code, for my structure, for all of it. So that is awesome. So that's where we're at today. I'm going to keep working at this and we'll go from there.